Hello, everyone. It's good to be here. Just to be clear from the start, I'm not going to talk about the reason not to use Xamarin, but I'm going to talk about why not use Xamarin. I know that all of you are native developers on iOS, but at least know about and consider Xamarin, and we will see why. By the way, is somebody here already using Xamarin for development? No. Great. My name is Aedelean. I have a small company in Italy, and we do training, consulting, and cross-platform development. So how many of you did work with C# as a programming language? So I have a great public. So we will talk about Xamarin, and we will see that Xamarin is not only about development. So we will talk about development using C#, but all the other parts in application lifetime cycle, you can use it for both application developed with Xamarin tools, but also with native application, the one you developed in ObjectiveC or Swift with Xcode, or Java with Android or Windows application. So the infrastructure of Xamarin has a 360 degrees look at application lifecycle development. So we start with develop, then we have solution for testing, for building, distribute, and monitor your application. We will start with the development part. And when we talk about Xamarin and application development, we talk about native development. All the application developed with Xamarin tools on iOS and Android are native application. What makes an application native? I think there are three major areas that make an application native. The first part is native user interface. So each operating system, Android, iOS, Windows, has its own design language. So the user, when it uses the application, it usually expects to have the look and feel of the operating system. Then we have to have access to full access to the SDK of the operating system. And then the third part, the application need to be really fast. So they need to have to be fast and fluid. The classic approach right now, the one that probably you are using, it's having multiple teams development for each platform with the platform tool. So you'll have the iOS team developing using ObjectiveC or Swift using Xcode. You have Android with Java, Android Studio, IntelliJ, Android or Eclipse. And you have Windows with C# and Visual Studio. The big problem of this approach, it's not a problem, but it's a challenge, is testing on all three platforms. So you cannot share directly code from let's say, Java to Swift, from C# to Swift. Then you have to have multiple teams for each part of the application. That part has to be validated. Let's say only for the communication part with the server. You have one web service, and then you have three teams that do the communication, so you have to validate and develop and fix 3 times the same thing. The Xamarin approach is enabling C# for developing on iOS and Android. What do we get? We get that we can use C# on both client-server, so we can share code models, for example. We can share code between mobile application and the web part. On the web part, we can have Azure, we can have the .NET Core, which runs now also on Linux and macOS. We have Entity Framework Core that runs on all the systems. So we have one layer of code that we can share. The only thing that we cannot share right now with this approach, which is normal because we said we want native UI, is the application UI. So what we can share right now on the mobile side, it's everything but the user interface. So we can share the communication layer. Everything we can do with HTTP client, which is C# class, then falls back to the native class on Android and iOS. We can share the data layer, so on all the operating system, including Windows. And when I say Windows, don't consider Windows Mobile, consider Windows 10, where with Universal Windows Platform, we can go from IoT to phone, to desktop, to Xbox and HoloLens. So we can use that. So we can share the data layer with SQLite. We can share the models. We can share the business logic, and we can even share the validation of the UI. Xamarin also created another framework, which is called Xamarin Forms, which is a framework for creating cross-platform native UI. What does it mean? It means that you have objects, abstract objects, like a button, like a label, that when running on each system becomes a native control. So it has a renderer on the platform, and the label for the iOS becomes the UI label. It's an extensible framework. We can change the renderer. We can attach effects. It's pretty used right now, and it's easy to develop. We will see a demo on this one. So, the big question, why use Xamarin? Remember that 100% of the thing that you can do with ObjectiveC, Swift, and Java, you can always translate them in C# and use Visual Studio and Xamarin. It is now open source, and the community edition is free. So the Xamarin Tools community edition means for teams with less than 5 developers is free. Open source on GitHub, which means you can fork it, you can modify, you can contribute, and do pull requests. Why C#? C#, because a lot of you already use C#, because I saw that. No, but C# is really awesome. When you say Swift is awesome, also C# is awesome. Think about C# is the Swift, the way Swift is for Objective-C, it's the same C# for C++. So what do we have? We have link support if you already work with it. We can easily work with XML, events, delegates. We even have a lot of packages on NuGet, portable class libraries on NuGet or Xamarin Store that we can reuse. For example, for JSON, if you develop in C# and use JSON, you probably use JSON.NET, which is the library to manage, to easily manage JSON. And also for some things, it simplifies how the code looks. So I have a small sample with the Objective-C and the counterpart of C#, C# using async and await, asynchronous methods. It simplifies actually the same instruction that you see in Objective-C, and it makes it a little bit more readable. So how does it work under the hood? We say native application. How does it work? It works different from Android and iOS. On iOS, we write in C#. We have bindings on 100% of the SDK. And then, when compiling, we have the compiler, the Microsoft Build compiler that creates interpreted language. And then we have a cross-compiler that translates the interpreted language into ARM code for the device. So you can say that for the App Store, when you upload a package created with Xcode and upload a package created with Xamarin, there is no difference. There is a little bit of difference in the size of it, because, for example, if you add the JSON.NET library, that one, it's only 1 megabyte. So once you add it, you just increased the dimension of your application by 1 megabyte. Everything is ahead of time compiling. On Android, it works differently because we have the Linux operating system. So for the application, when it runs, we actually have 2 runtimes running in the same process. We have the art runtime, which is the Java one, which we still need because all the UI on the Android operating system is created in Java. So for the Xamarin tools to work and create UI on Android, it creates proxy objects that invokes the Java counter object. And then we have the .NET runtime running on Linux, which for the graphical part or some Java function communicates with Java native invokes the native functions. And for other things, like the framework itself, it goes directly to the operating system. This is why in some tests, if you look, Xamarin Android applications are faster than the counterpart developed in Java. Also, Xamarin is doing the binding, because everything is a binding. So you have the iOS SDK, and Xamarin binds all the SDK, so you have all access to the all functionality in new SDK. So Xamarin actually gives same-day support for iOS SDK, usually in 24 hours from the release of the SDK to the public. We have an update to Xamarin that enables all the functionality. The same thing for Android, but for Android, the times are a little bit longer for binding. But this is not a problem. It's like 1 month. But this is not a problem, because from the time the SDK is released for Android to the time that that operating system becomes relevant to the market, it takes a lot of time. So 1 month, I don't think that anybody who's developing for Android, when the new SDK is ready, has the same security to go with the new SDK, knowing that the market share for the next year will not be considerable for that operating system version. Then for the development tools, we have Visual Studio. With Visual Studio, we can develop for Windows, of course. We can develop for Android, but we can develop also for iOS. How does it work? Because if somebody knows the EULA of iOS development, if you develop for iOS, you have to compile on a Mac machine. So the way it works, you can have a remote machine in the cloud with macOS for compiling, or on your network. So that machine has a Mac agent, and Visual Studio communicates with the Mac agent. Then also in Visual Studio, really nice. It's still in preview. We have an iOS simulator remoting. So they are remoting the simulator that runs on the build machine. And not only remoting, but if your Windows machine has multi-touch and pressure sensitive, the emulator, the simulator on the Mac machine becomes multi-touch enabled and pressure sensitive. It's fast, it supports location. And the big part is you never have to leave your Windows machine or your Visual Studio development environment to do the testing. Then there is the Visual Studio iOS USB remoting. This means that, also in preview, this means that you can connect an USB iOS device on your Windows machine and deploy and debug on it using this remoting mechanism. And then there is Xamarin Studio. Xamarin Studio, it's a development environment, an EDE, that runs on the Mac. You can only develop for iOS and Android. They are enabling now Azure development. And it's really cool because you have designers, you have code completion, you have integration with Subversion and Git repositories, and you can create application for iOS and Android. As I said to you, there is a designer for iOS, both in Xamarin Studio and Visual Studio, where you can develop, you can design your storyboards, your zip files directly here, but you can also import them from Xcode. So if you have a project that you try to migrate and share more code, or somebody that it's doing your UI directly in Xcode, you can just take the files from the Xcode and import it in the project, and you can use them. Then there is the Android designer, same thing. So we can create user interface. On the iOS designer, I can also do constraints. I can do anything that you can do on the designer on the Xcode designer. You can usually do it on the iOS designer. On the Android designer, same thing, drag and drop designer. And also in this case, if you already have the designed layouts in Android Studio or another IDE, you can import them and use it in Xamarin Studio and Visual Studio. Now, let's talk about the Xamarin Forms. Xamarin Forms, it's really important because it enables you to write your user interface once and deploy a native UI on each platform. So you can easily use it for prototyping, when you need to prototype an application. You can use it for a data entry application. You cannot use it for everything, because if your application is more user interface than data layer, you will go with the classic approach when we're using Xamarin iOS or Xamarin Android without Xamarin Forms. Also, we will see in the demo, it supports theming, so we can easily switch between dark theme and light theme. The concept exists on iOS, on Android, and Windows for a long time. Now also in iOS, but it's not so easy, as far as I know, implemented. But you can do theming, so you can derive your own theme for your own application from the dark and light theme. You can make it personal. So what is included in Xamarin Forms? We have more than 40 objects between pages, layouts, containers, and controls. Then we have very important two-way binding. So we have data binding, bidirectional data binding. We have navigation service. We have animation API. We have dependency services, so we can inject native functionality. We can inject native functionality in your code. We have a messaging center for create a message bus. It supports model view model of as a design layer. So I'm going to do a little demo on Xamarin Studio. Let's see if it switches. OK, so right now what I have a cross-platform project using Xamarin Forms that deploys on Android and iOS. How did I create it? I do file, new solution, and I can select the type of project I can create. Also, I can select if I want to do a C# project or F# project. So I've launched the Xamarin Forms apps. I give it a name, and it created me the project. The project, if you go on iOS, you'll see that it's very similar as a project that you have in Xcode. I have the info plist with all the settings of the application. I have the entitlements. Then I have the resources. And then in the app delegate, what I do are only 2 lines. So I'm initializing the Xamarin Forms framework. Initializing means that I'm injecting native functionality in the framework, and then I load an application that it's declared in my other project. Also, see that the class AppDelegate, it's derived from a Forms application page delegate. This way, my application can bubble the lifecycle events to the Xamarin Forms application. So how does it look in the demo? I have my application, which in XAML I can declare my dictionaries with my resources. And what it does, it initializes the resources and then say the main page of the application, it's the Pragma demo page. And I can overwrite the lifecycle events. So on start, on sleep, on resume. How does it look, the page? The page is in XAML. So I have a content page right now with a stack layout, so a vertical layout where I have a label. The stack layout, it's centered both horizontally and vertical. And still in preview, there is the previewer. So I can preview while I'm writing the code. I can preview how it looks on iOS and Android. So the way it looks, I can do, let's say, I want to add an image which has a source from the resource. It's called Pragma. Okay. And I see that it's too big, so I will say width request equals 100. Okay. And it's too near to the label, and I will say margin equals 12. Now I can add a button. And I'll say the text of the button is hello. And you will see here already that the UI, I'm on the dark theme. This is why you'll see everything in dark. This is the iOS look and feel, and this is the Android look and feel. So I can easily see them, that they are different. So what I can do right now, I will do a clicked event, handle clicked. I will put it here. And no, it did not close. And now I will give it a name to the image, and I'm going to rotate it. So in the code behind, I will say img Pragma. I had to compile, but rotate to 360 degrees in 800 milliseconds with an easing linear. This is an async method, so I say async method, await that it finished, and when it arrives at 360, just rotate in to 0, 0. This way I can start it again. So just like that, I have my application. I debug it on the simulator. I press hello, and it will rotate. I get the same thing on Android, but only with the Android feeling, without changing anything. And with the latest version of Xamarin Forms, still in beta, I can inject native controls directly in the Xamarin Forms. So I can insert from template. What I do, it should be okay. It just doesn't see. I inject an iOS UI label on the iOS, and I inject an Android widget, a text view from Android directly here. So I can have, when there are controls, user controls that exist on a platform and don't exist on the other one, I can still work with them and inject them. So what I will get, if I run this, I should only see the UI label. And with the UI label, I work with all the properties of the UI label. If you look on how it is initialized here, to give the horizontal options, it's not like a Xamarin Forms. It's not like a Xamarin Forms object, but I go with the view, and I arrive at the view and set the horizontal options. So if I go back here, still doesn't like. So oh, of course, I put them out of the stack panel. Okay. So now I should see if everything builds. I should see only the iOS label. There is still content page, stack panel. Let me see. The previewer, I'm not relying on the previewer because it's still in beta, but I'm going to insert the template again. Pragma native controls. Okay. I'm still missing the namespace. So I'm missing the namespace. Sorry about that. I'm missing the namespace, so I have to insert the namespace because it doesn't know what is iOS and Android. And now it should work. Waiting for the debugger, and it runs. And you can see that the text color is black. It did not apply the theme. Also, the theme part is in preview. When you put the NuGet package, you have to select the preview for the packages. So this is the development part, and it's just one of the blocks of Xamarin platform. Let's see. Then we have the test part. So from now on, consider that you can do all the things I'm talking about for Xamarin developed applications or application developed in native, so Objective-C, Swift, Java. For the test part, so test quality on mobile is hard, mainly because testing is hard. We have a lot of devices, a lot of languages, a lot of operating system versions. So we are limited, when testing them, we are only limited to what we have in the house. So Xamarin created a testing framework, which is called Xamarin UI Test, where using CSharp, you can create UI testing on your application, on both iOS and Android. And then if you don't want to write it, there is a test recorder, so a Mac application and a component in Visual Studio, where you launch your application, you play with your application, the recorder records your actions, and then it generates the script for the UI testing. And one, you have the testing script, you can deploy your application and the testing script in the cloud. And we have Xamarin Test Cloud, which is a cloud of physical devices, thousands of physical devices located in Europe. And when you deploy your application with the testing sequence, you can select the devices where you want to test your application. When I'm saying testing, it's not only inserting, clicking, you can also simulate GPS position, you can simulate gestures, you can simulate rotation. So you deploy your application, select the devices. You can also take screenshots of your application. You select the devices, start the testing, and it will tell you if it had error or not. If it has error, it gives you both the native stack and the .NET stack. In your case, if it's native, only the native stack. It gives you screenshots where the application crashed. So you can look at it and see what's wrong on running your application on those devices. Then you have the build. For the build part, you can use Visual Team Services, Studio Team Services, because it enables you to do everything from coding to releasing. So coding, you can start a project and you select, you have both Git repository options or Team Foundation Service repository. You can select Agile, Scrum, then you have the repository, then you can do all the sprints, all the bug management. Then you can do build scripts, which is pretty important, build scripts in a continuous integration, continuous delivery kind of way, because everyone is moving right now, also Windows, Microsoft Windows, to a continuous integration, continuous delivery, and then you can release it. So here is a screenshot of a build sequence taught in a continuous integration, where starting from your commit on the repository, the application compiles itself, it attaches if we want the test cloud, it tests on the devices. If it passes the test, it can publish a beta or an alpha or release it to the public, depending on what you want to do. It integrates with both Xamarin Test Cloud. So if we want in the Visual Studio Team Services, we have the Xamarin Test Cloud integrated. and also with the Hockey app. Hockey app, how many of you used Hockey app? So you know that Microsoft bought them. Also Xamarin in the end. And you can use also Hockey app directly integrated for both native iOS and Android or Xamarin application directly in Team Services, or you can use it separately, like the Test Cloud. So the distribution and monitor part, there is the Hockey app. So the ones you already use it, you can manage the crashes from various versions, you can monitor your application, how your application goes, and also distribute the application alpha, beta, or stable channels. Oh. So we've seen that with Xamarin and ultimately Microsoft, because actually the develop, test, it's Xamarin, build, it's Microsoft, distribute and monitor, it's Microsoft, but as they say, it's one Microsoft, so Xamarin tools cover from development, testing, build, distribute, and monitor. Thank you very much.